So I welcome you all for this Sniper series where today we are going to discuss the most important questions from the physical pharmacy, biopharmaceutics as well. Let's wait for a few more students to join the session. Very good evening. So these questions, these series will actually enable you all to keep a check on your preparation just like you did in the GPAT exam, and I hope it went well. For the NIPER exam as well, we have framed multiple questions based on your biopharmaceutics as well as physical pharmacy. Very good evening, very good evening. So let's start with our first question of the day. So the first question says dipole-induced dipole interaction between the molecules is also called as, the question itself is from the NIPER JEE 2 2023. That means it is a very recent topic and you have seen that this was also marked important in every class. So you all know the interactions are basically classified as dipole-dipole, dipole-induced dipole and induced dipole interactions, right? So for this we have dipole-induced dipole interaction, which is known as your D by forces, right? If it was dipole-dipole interaction, it would have been the Kezham forces. If it was induced dipole, it would have been the London forces. So for the dipole-induced dipole interaction, we have correct answer as the D by forces. So today we have a lot of MCQs to discuss. So I want you all to be active, to be answering each and every question. Okay. So next question, let's see. So question says the Km value decreases, option number A, in the uncompetitive inhibition model. Option B says competitive inhibition model. Option C says mixed inhibition model, or none of these. So before we even proceed, you must understand the what is actually the, yes, all the PYQs will be solved for both physical pharmacy as well as for the biopharmaceutics. Do not worry. Expected GPAT cutoff, already the video is live on the main GDC channel. Please check out for that. Right. So for the Km value, you must understand. So Km basically measures at the substrate concentration, mainly at the half the Vmax, half the maximum velocity, right? So in this case, for the competitive inhibition, we generally mention that the value of the Km generally increases for the competitive inhibition, but for the uncompetitive one, the value of the Km generally reduces. So that is why the correct answer stands for the uncompetitive inhibition, right? So Km value basically decreases for the uncompetitive and increases for the competitive. However, if question is reversely asked for the Vmax, for the Vmax in the competitive, the Vmax remains unchanged, but in the non-competitive, the Vmax also reduces, as you can also see here. Sorry, for the uncompetitive. Okay, so value of Km and Vmax reduces. Next question. The van der Waals equation explains the behavior of. This is a very straightforward question. No concept applied. It is a 2022 question, right? So the van der Waals equation mainly explains the behavior of none other than our real gas. The question has nothing to target on because it's a simple question. I hope this does not have a problem with, right? So it will be real gas behavior. Okay. In these only the van der Waals forces, we have already seen the classification of the forces based on the nature and the type of the molecule, its polarity also, right? Next, in the eutectic mixture, the composition, I can still see very less students are active. So I want you all to be little attentive because we have a lot and lots of questions to discuss today from both physical pharmacy and biopharmaceutics. Okay, so in the eutectic mixture, the question says the composition at which the lowest melting occurs is called as eutectic point, solidus line, liquidus line, or the critical point. First and foremost, Because the name itself mentions it is a eutectic mixture, which includes where the composition, whatever the components are present in the combination of one or two components, the melting point will be much lower than the melting point of the individual component. So for the eutectic mixture, it will be the eutectic point. But if somebody asks you what is this solidus line, the temperature above which the component will act as a solid, and for the liquidus, for the temperature, it will act as a liquid component, and critical point has nothing to do with the eutectic mixture. Okay. So correct answer will be eutectic point, although it was very much evident with the name itself that it will be eutectic point. Next, pegylation of drug is used to do what? It improves solubility, stability, toxicity, or all of these. So pegylation, basically pegylation, what is pegylation? Do you all know what is pegylation? If not, generally whatever carrier systems we have, in which our drug is actually loaded so that it acts as a carrier system, as a cargo. For example, you have a bag full of books, so that bag is a cargo which is taken by you to the department or anywhere else. So you load your books inside it. So just like that, your carrier system, this carrier system can be pegylated. So pegylation is very much known that it will help to improve the stability. It also helps to improve the solubility as well. So pegylation is nothing but pegylation is basically once the molecule or the carrier system is pegylated using the PEG polyethylene glycol as a substitute in the composition mixture of your lipidic carriers, it will increase the solubility, stability, it will increase its controlled exposure into the body as well as reduce the toxicity. Okay. Next, Keystone forces are also one more thing. Once a molecule is pegylated, means the PG chains are attached to that molecule, it will turn into a hydrophilic, right? So if you are having any hydrophobic carrier, the addition of the pegylation will impart hydrophilicity. Note this point, this is very important. Okay. Next, Keystone forces are related to, just like at the start of the video, I have mentioned that the dipole, induced dipole, dipole-dipole and induced dipole interactive forces are important. You must see that the Keystone forces here includes the interaction between dipole and dipole. That means both the molecules are polar in nature, right? In the Debye forces, it was one dipole and another was the induced dipole, right? So for the Keystone forces, we have dipole-dipole interactive forces. Very correct. The answer is A, correct. Okay. Next, let's see. Density can be measured by which of the following apparatus? So, even if you do not know the name of the apparatus, I must guarantee you that you must be aware of what is oxalate extraction. You have heard in the cognosy. What is Karl-Fischer titrator? You must have heard in the analysis. What is distillation apparatus? For the purification separation purposes we use in the pharma engineering, you must have studied. So the pycnometer is actually used for the density measurement, right? So this question was asked in the NIPER 2023 exam. Okay, so correct answer is option number C. Very correct, Dimple, Bhardwaj, Shivani, Vijay, 7th C, right. Okay, next question. If the CARS index is between 26 to 31, what will be the type of the flow? Will it be poor, excellent, passable or very, very poor? You must remember that the flow properties can be evaluated using three methods. We have the CARS index method, we have the Hausner ratio method, we have the angle of repose method. So we are talking about the CARS index. For the formula of the CARS index was tap density minus bulk density upon tap density into 100. You must remember the table as well, right? So if the value of the CARS index falls less than 10, it will offer the excellent flow. If it is 11 to 15, it will follow the good flow. So that is how they are asking the range between 26 to 31. So it is going to offer the option number C. Yes, it is correct. No, it is 26 to 31. It will offer the poor flow, right? I have misunderstood. So it will be the poor flow. Kindly note this table. It is very important. One simplest trick to remember this is that there is a gap of almost 4 digits here, right? You must remember less than 10 is excellent flow. 11 to 15, a gap of 4, it will offer good flow. 16 to 20, gap of 4, fair. 21 to 24, gap of 4, passable. 26 to 31, almost we can say 5 is there. So it is offering poor. 32 to 37, 5, right? So that is how you remember what is the actual value for the CARS index and what kind of flow it is going to offer. Okay? Okay. Okay. Next question we have. Under the BCS classification 1, you all know the BCS classification system famous for categorizing the drug based on their solubility as well as the permeability. So the drugs which have belong to the class 1, such drugs are known as what? Such drugs are known as to have the higher solubility and the higher permeability, right? High solubility and the high permeability. Class 1 drug. Class 2 drugs have low solubility and high permeability. Class 3 drugs have high solubility and low permeability, while class 4 drugs have poor solubility and poor permeability. Okay? Correct. Next question. So, next we have one of the following is related to not related to the flow properties. If you remember, while I was talking about the CARS index, I have mentioned that the flow properties can be evaluated using the Hausner ratio, CARS index, angle of repose, but no other method is used. So this bulk density is actually not used for the determination of the flow properties, right? So correct answer, it is going to be the bulk density, option number D. Right. Okay. Next question. You can already see how many questions have been asked from these topics over the years, right? So please pay attention. The correct order of bioavailability. Correct order of the bioavailability they are asking. So most of you already know the bioavailability is reduced based on the type of the route that the drug is being administered because of the systemic first pass metabolism. So in this case, we have seen the answer will be definitely from the parenteral, right? So option A is eliminated, right? Then they are asking about the rectal, topical, as well as oral route. Okay. So for the parenteral, then we have what? Yes. Correct. So here first we have for the rectal and then for the oral, parenteral, then oral, then rectal and then topical. You can already see the order of the bioavailability here. It is for the parenteral first, then for the oral, then for the rectal, for the topical. One conceptual thing I would like to add here is generally in case of the B pharma level, we say that the drug once it is administered directly into the systemic circulation, that is involving the parenteral route, it is said to be available 100%. That means it is available in the blood circulation, so it is not going to be metabolized by the liver. We all have literally heard for this thing only. But let me clear this off. Once your drug is entering the systemic circulation, most definitely it is also going into the liver again. Okay. So it is not a 100% correct statement that because it is available in the blood doesn't mean it is going to get absorbed at the target, right? So this statement is very much confusing to say that once the drug is administered parenterally, it will be 100% available. This is a conceptual thing which will you can use later on. Okay. Okay. Particle size is used. Yes. Particle size used in the sedimentation method. So for the particle size determination method, you all have seen there are sieving method, sedimentation method, right? we have optical microscopy, we have Coulter counter method. So based on the size of the particle that is obtained from this, all these methods are different. So they are asking about the sedimentation method. For the sedimentation method, we have 1 to 200 micrometer. This is which is not visible, it is a micrometer only. Okay, right? So this basically for the sedimentation method, three apparatus, three methods we use here. We have the Anderson pipette method. I'll write here. We have Anderson pipette method, right? Second we have is balance method. Third we have is the hydrometer method. One more thing you must remember from the sedimentation method is the Stokes law equation. So the Stokes law equation based on the rate of the settling of the particles deals with the diameter of the particle as well as the viscosity, right? So this is the equation that you should not ignore at all. Okay, so I hope this was very much clear in your GPAT exam also, but even if it is like not, but you can still revise it and add to your important list. Okay, right. Next question, high plasma protein binding. This is from the biopharmaceutics mostly. Yes, it is asked in the 2023. So plasma protein binding, the drug has two fates once it enters your body. Either it is going to be plasma protein bound, either it is going to be the more of the tissue bound, right? So the plasma protein binding is inversely proportional to volume of distribution. Just remember this relationship and your queries will be sorted. So if the drug has higher VD, it should be having the less of the protein binding. If a drug has less protein binding, that means it will be more tissue bound. Okay, so the drug, the volume of distribution and protein, if the drug is more protein bound, it is generally pharmacologically inactive. That means the ADMEs are going to get altered. Okay, so that is why the volume of distribution, half-life, everything will be altered. So this relation you must remember. A high plasma protein binding will indicate a smaller VD. Okay, correct. So option A here is correct. Right. Okay. Next question. Flowability of a powder can be measured by, just we have discussed, I think it does not need any repetition. Definitely Kar's index is one, definitely angle of repose is one, right? So both A and B, I hope it is clear. Sedimentation method we have seen in the particle size determination, not in the flow properties, right? So option C here is correct. Good. Okay. Next question. For the good flow properties, for the good flow of powders, Hausner ratio, just like the Kar's index, the Hausner ratio is also categorized, right? So Hausner ratio is tap density upon bulk density, right? So similar to the Kar's index, the flow is categorized based on the value of the Hausner ratio for the particular powder. So they are asking about the good flow, right? So for a powder to have a good flow, generally it will be in the range of 1.12 to 1.18. Right, option B is correct. Yes, most of you have got right. Just remember this table. This is a very important table. It will cover both your Kar's index as well as the Hausner ratio also. Okay. Okay, next, volume of distribution. This is again, you can spot that this question is from 2023. So volume of distribution, what does it actually mean? Volume of distribution means that how much drug is actually distributed across your body. This is what it means, right? How much drug is actually distributed across your body and in how much concentration as well. Okay, so this volume of distribution is, if you want to put into the formula, it is equal to, volume of distribution is equals to amount of drug upon plasma concentration, right? So this is the basic formula, is X upon VD. So in this case, Vijay, you are answering for the 17th question. I have just reached in the 16th question. How you have managed to go further than that? So please concentrate. So in this case, you can already spot that the correct answer is going to be none other than the option number A, where the concentration of drug in the body upon the plasma concentration. Yes. So not only that, please Please have a look at these formulas. For the biopharmaceutics, direct formula based questions can also be asked. For the clearance you can remember one more formula, Ke into Vd, right? Clearance, this another important formula, Ke into Vd. Ke will be the elimination elimination constant. This Vd will be the volume of distribution. So if you want to correlate it with the previous formula, volume of distribution is none other than your X upon Cp, right? So that is how you can switch to other formulas as well. So volume of distribution is X upon Cp, right? Then we have elimination half-life for the first order, you know it will be 0.693 upon Ke. Okay, so this can be substituted again as this formula as 0.693 upon T half into volume of distribution. So that is how the questions can be switched. Okay, last but not the least, we have the extraction ratio. The extraction ratio will be concentration of drug in versus out, right? So note this down also. Sometimes direct formula based question are asked. Okay, next question, let's move on. True density can be measured by, if you have seen the picnometer question, there was the chart in the explanation where you can already spot that what are the different methods that can be used for the granular density, true density, right? So for the true density, they are asking, is it the liquid displacement method? This is correct. Is it the gas displacement method? This is also correct. Is it the by floating into the liquid? These all methods are correct. So we have all of these as the correct answer to this question. Okay. So mark this as correct answer, option number D. All these methods are used for the determination of the true density. Next, which of the drugs has a longer half-life? This was asked in a recent 2022 exam. Okay, so alprazolam, diazepam, warfarin and chlorquine. So by the time you answer this question, I know most definitely you are very much aware of the exceptional characteristics of the anti-malarial drug, which is the chloroquine, right? This chloroquine with the significant volume of distribution as well as much higher, longer half-life. You can just spot the correct answer with the most famous anti-malarial drug. Okay. So correct answer is going to be the chloroquine. Okay. So benzodiazepine, which are known to be the have the short acting, right? So next we have chloroquine, which has the half-life you can already see. Okay. Even I am very much doubtful how can it be so much, but definitely it will have either the extensive tissue binding, which is written here. But anyways, just focus on this. Just a second. Okay. I think there is a issue with the question here. It is not showing. Anyways, they are asking about the formula of the Cars index. Let's write it in our own way. It is mentioning tap density into bulk density. There must be other formulas as well. So this is definitely wrong. For the Cars index, it is none other than the tap density upon bulk density. Tap density minus bulk density upon tap density into 100. This is going to be the formula for your Cars index. For the Hausner ratio, it was tap density upon bulk density. Okay. So the correct answer any which way will be the tap density minus bulk density upon tap density into 100. Correct. Next, full form of ADME. This is such a simple question from 2022 Biopharmaceutics. Basic question they are asking about the ADME. What is ADME? Only I think the confusion can be from the excretion or the elimination. Rest is should be all clear. Please answer. Yes. So it will be the absorption, distribution, metabolism and excretion, right? ADME. Option D is correct. Very good. Okay, next. Wilme plate method is used for the determination of what? Before you answer, kindly see it was asked in the just last year surface tension question. I have told you the trick initially in your recorded videos as well. You can spot. If not, please see methods for the determination of surface tension. I'll tell you one trick. Wilme dropped CD and ring in tension. 𝙂𝙋𝘼 dropped CD and ring in tension. So this 𝙂𝙋𝘼, this is none other than our 𝙂𝙋𝘼 plate method, right? Dropped means drop number or drop count method, or we say drop weight method. Alright, then we have CD. C refers to the capillary rise method. Then we have ring, that means ring detachment method, or the main instrument is 𝙂𝙂𝑡entiometer. Okay, this is the easiest way you can remember. Yes, Shivani, 𝙂𝙋𝘼 dropped CD and ring in tension. So in tension, he has dropped the ring and the CD. Who? 𝙂𝙋𝘼. So we have seen the specific gravity, no, surface tension will be the correct answer. One more important point to note here. All these methods which you can spot here are for both surface tension and interfacial tension. But this capillary rise method is only specific to the surface tension determination. Right, very correct, right? Rest all are for both surface tension and interfacial tension. Very correct, right? So we have option B as correct. Okay, I have repeated these things so many times, but I am telling you over and over again. So these things just fix in your head. Okay, next. Creatinine clearance is used to measure tubular secretion, glomerular filtration, passive renal absorption, or renal blood flow rate. So creatinine clearance is basically, while you have studied for the GFR, glomerular filtration rate, you must have seen for the determination of the GFR, we use one endogenous compound, one exogenous. For the endogenous, we have creatinine. For the exogenous, we have inulin. And the rate of the GFR is 125 ml per minute. Okay. So creatinine clearance is attributed to none other than our glomerular filtration. Very correct. Okay. Yes, one more thing you must focus here. I think it is not mentioned here. Anyways, the creatinine clearance, basically the GFR is measured by the creatinine only. Next, what is the surface tension of the oleic acid? Another question, such question was also asked for the mercury as well. So in the recent GPAT exam. So yes, these type of topics are also very much repeated. So kindly see the surface tension of oleic acid is 32.5. How you will be able to memorize all those? Let me tell you one way you can just have an idea of the surface tensions. See, by now, if you have been like really together for the physical pharmacy since day one, you should have the idea of for the water. It is 72.8, right? For the water and glycerin, just remember for the water and glycerin 72.5. See, we have only few days left, right? Very few days left for your exam, right? So this is the time you just brush up, polish up your preparation, and few things are not meant to be like, even at this stage I never remember that what was the surface tension of the oleic acid. For water it is well known, but for the other compounds you have to do that ratta thing only, right? So for let's fix what can be grouped together. So these oils you can see, these oil classification you can see, they are in the range of like 30, 33, 35 only, right? So you can club these. Then for the chloroform and for the these three, chloroform, benzene, right? So you can remember BCC, benzene, chloroform and carbon tetrachloride. These are also near about like 26, 27, 28. And for the you can spot for the water, for the glycerin, we most of you, I hope you remember that. For the oleic acid, it is placed in between, that is 32.5, right? So please just by looking at it, you must remember this is the value of the surface tension, right? Similarly, we have interfacial tension also. So this was asked, I think, in the GPAT 2025. So this table definitely is important. Again and again it is shown to you. It is, I still recommend you all to spend at least 2 to 3 minutes and have a good screenshot of it saved. Okay. So We have hexane and benzene near about 51 and 35. We have oleic acid. See, oleic acid, let's suppose the surface tension is around 30. Let's assume the surface tension is 30. Interfacial tension is half because it is at the border, at the interface. It is half. So half of it, 30 half, it will be 15. You can remember like that also. Okay. For the octyl alcohol, it is around 8.25. For the caprylic acid, 8.2. For the olive oil, it is 22.9. For the ethyl ether, it is 10.7. This much effort I need from you all. Please try to remember these. Okay, these are not going to go waste. Okay. Next, which is the not the transport mechanism? Paracellular transport, right? Transcellular, we have known the vesicular transport as well, where we have mentioned dissolution to be a transportation mechanism, right? So this is wrong here. So we do not include dissolution as a transport mechanism. Rest all have transport in their names as well. Okay. So it was also asked in 2022. I think from in the GPAT, very less questions are asked from the biopharmaceutics. But in the NIPER, simplest questions are from the biopharmaceutics only, right? Most of the question I can spot are very simple, which are asked from the biopharmaceutics and direct. Okay. Okay, next question. The HLB value of the surfactant which is acting as a wetting agent 2022 2024. So, based on the classification of the surfactant based on their HLB values, we have already put them as ODS, right? ODS. So, this A will be anti-foaming agent. This W will be water in oil emulsifier. Next W is this wetting agent. This O is oil in water emulsifier. D is detergent. And S is solubilizing agent. Okay. So the value starts from 1 to 3, 3 to 6, 7 to 9. So this you can spot the value of the wetting agent as 7 to 9. So we have correct answer as option number B. Okay. I hope you all get it right. Option number B, 7 to 9. Correct. Next question. So we have zeta potential, which is used to determine surface tension, interfacial tension. Have I ever mentioned will may drop the CD and ring in tension? Zeta potential is not included. So stability or kinetic profile. Based on the quartz dispersions, biphasic systems, there should be a good control over the stability, which is attributed to their nature. They can coagulate, they can flocculate, or make the system unstable. So zeta potential gives an idea about their stability. Okay, so we have option C, stability is indicated by the zeta potential, right? So a higher zeta potential will indicate the better stability, as if the repulsive forces are much more present. Okay. Next, which of the following is not an important parameter for the plasma time level studies? So once you are doing the plasma level studies, which of the following it says is not the important parameters? Cmax, definitely it is important. Tmax, then it is says AUC or steady state. Steady state is actually achieved once the infusion rate and the elimination rate are supposed to be at equal, right? So in that scenario, we say that steady state has been achieved. So during that, we take in account for the loading dose and maintenance dose, not for such plasma level studies. As of a direct answer, if you want, right? Although definitely it is correlated, but for direct answer is the option D is correct. Generally, for the main pharmacokinetic parameters, we have Cmax, Tmax, and AUC. Okay. Next question. The HLB value of tween 80. It was asked in 2003. So tween 80 is actually what? Tween 80 is a surfactant, is a your non-ionic, your surfactant classification we have cationic, anionic, ampholytic and non-ionic hydrophilic surfactant. Okay, so in the classification of ODS, I have mentioned it is a hydrophilic surfactant. We have to go down to the solubilizing agent, we have to go down to the detergents, water in oil emulsifier, right? So in such cases we have then oil in water emulsifier, ODSO, oil in water emulsifier, right? So this tween is none other than having a value of 15, which is supposed to be your oil in water emulsifier. Not only that, I will mark some of these important as well. Please note it down. For the names you can spot as much as you can spot. For the bridge 35 we have around 16.9, right? For the bridge 45 it is around 11. Note it down, 5 star, note it down. Okay, then we have for the pharma gel, which is gelatin, it is around 9.8. For the bridge 30 we have for the 9.5. Remember their names, it is polyethylene lauryl ether. We have polyoxyethylene lauryl ether. For the next we have polyoxyethylene monostearate. Okay, then for the tegin also, for the tegin we have around 5.5. These are some exceptions you must remember. Okay, next the intravenous infusion, the steady state, the rate of elimination at steady state, the rate of elimination is GPAT 2020. Just before this question I have mentioned that once we are talking about the steady state, it means the rate of the drug that is being administered as well as what is being eliminated is said to be equal, right? So at the steady state, the rate of elimination, it is going to be equal to the rate of infusion. Okay, so option B must be correct, right? Okay. Yes. Next, chemical name of span. See, once we are talking about the classification of the surfactants, you should remember that we have cationic, we have anionic, we have ampholytic and we have non-ionic ones. For the non-ionic ones, we have hydrophilic surfactant, we have hydrophobic surfactant. For the hydrophilic, we have tween. For the hydrophobic, we have span. Alright. For the hydrophilic tweens, these are none other than our polyoxyethylenes. Okay. And the spans, we have sorbitan esters. Right, S for span, S for sorbitan ester. So chemical name of span 80 they are asking. Also we have different grades of the span and tween. So you can say LPSO, laureate, palmitate, stearate and oleate, right? So span 80, 20, 40, 60, 80. 80 will be oleate and it is talking about span. So span is a sorbitan ester with a mono-oleate. Okay, right. So correct answer will be option number C, sorbitan mono-oleate. Okay, next compartment modeling. Some questions are like really direct. Please read out. Compartment modeling is related to bioavailability, study of drug absorption, study of drug disposition or drug elimination study. Yes, so when you are considering your body to be framed as a compartment, we must understand that the flow of the drug once it is administered into your body is considered hypothetically entering into these compartments and we mark their passage based on the series and the parallel type of compartment, single or multiple compartment. Okay, so this compartment modeling is actually focusing on the study of the drug disposition, where actually it is going. Okay, so option C. Also, it does not include the barriers. Please mark it. The compartment is a hypothetical pool of blood or tissues, you can assume, which is considered as a compartment in which some amount of drug is entering, some is leaving, as well as the barriers are not considered here. Okay. Next, the type 1 adsorption isotherm is explained by, in the surface tension part, you must have covered this type 1 adsorption is actually explained by both the Langmuir as well as Freundlich isotherms, right? Okay. Next, in one compartment modeling, the concept body assigned as, body is assigned as what? I have just told you the body can be categorized as a single or multiple also, but if it is categorized single, it will be homogeneous. Single is correct, homogeneous is correct, heterogeneous is not possible. Okay, we generally categorize the body as a single homogeneous unit, right? Just as I've mentioned, it is without the barriers, because we are studying about the disposition studies, but we do not relate to what membranes are there, what kind of binding it is there. It is not very much considered once it is considered a one compartment model. Okay, so the correct answer will be option number B. Yes, correct. Okay, next question. Drave's test is used for the following: wetting agent, suspending emulsifying agent, or disintegrating agent. Wetting agent test, wetting agent efficiency is tested using this Drave's test. It is well known from the GPAT exam. It is very much clear from your point of view as well, as it should not have any query here, that the wetting agent efficiency is basically correlated with the Drave's test. So this wetting agent test can be categorized into a trough test, important, contact angle method, Drave's test, and empirical test. Okay, empiric method. Then in the contact angle, which is very much related to the wettability condition, contact angle and wetting is inversely proportional. That means if the contact angle is more, the wetting will be poor. Okay. Next question. MIC stands for, MIC, where have you heard about this? So once you were talking about the actual drug exposure into the body, MIC stands for the minimum inhibitory concentration. Okay, so MIC is minimum inhibitory concentration, option number A. Option number B, sorry, minimum, it is okay, minimum inhibitory concentration, it was maximum, that is why minimum inhibitory concentration. We have two more, right? If you remember, we have maximum safe concentration or tolerable concentration, as well as minimum safe concentration. Okay, minimum effective concentration. MEC, we have MSC also. Okay, and one is MIC. Next question. Anti-foaming agents act via increasing the surface tension, increasing the solubility, reducing the surface tension, reducing the contact angle. Please see, remember, anti-foaming agents are from the class where we have heard about the HLV. HLV is measured for the surfactants, which contain both hydrophilic, lipophilic groups. Surfactants are meant to reduce the surface tension, right? So it is correlated that way. So option C is going to be very much correct. Okay. Next question. Loading depends upon the, loading dose depends upon the, just we have started the steady state part. I have mentioned that concept for the infusion and elimination is applied for the calculation of the loading dose and in the maintenance doses as well. So this loading dose is actually correlated with the none other than our volume of distribution. If you remember the formula of the maintenance and loading dose, the correct answer is going to be the volume of distribution. Please note the formula for the loading dose. It will be steady state concentration into volume of distribution upon your bioavailable fraction, right? This is CSS into VD upon F. Okay, this is the formula for the loading dose. Okay, next, the HLV value of tween 80 is, please see, this is a numerical question. Okay, the HLB value of tween 80 is 15, span 20 is 4.3, and the required HLB is 12. Calculate the proportion for both of these surfactants. So in this case, students, it is clear to us that they are asking about the required HLB. So required HLB says fraction of the composition of the first surfactant into the HLB value of the first surfactant plus 1 minus fraction of the second surfactant into HLB value of the second surfactant. So we have a required HLB of 2. We have the first fraction which is not given to us. Let's assume it is F and the value is F15 plus 1 minus F we have here. The value is 4.3. So now you just have to solve this value of F in this case. Whatever value of F you will get, that will be the fraction. It is very simple. It will be 12F is equal 12 is equals to 15F plus 4.3 minus 4.3F, right? So very simply you can get the value of F. I am not going to take time to solve it. You can do it on your own. It is very easy. So you will get the value of F as near to 0.71, which will be equal to 71% or something, right? So 71 point something percent, which is nearest to our option number A. Remaining will be 100 minus 71, right? Or 72 if it is, it will be the 28%. So we have correct option as option number A. Okay. Next question. Non-linear pharmacokinetics is related to dose, half-life, volume of distribution or clearance. Non-linearity arises with the saturation, where the saturation starts. So which has nothing to do with these points, right? So it is clearly relevant to the dose, right? So non-linear pharmacokinetics is relevant to the dose, right? Okay. It is a dose dependent kinetics, mixed order kinetics, which is shown by the Michaelis-Menten equation. Next, which of the following is a non-ionic surfactant? Today we have talked about it. Non-ionic surfactant, we have spans and tweens. Right? Correct answer. Also, please remember tween is going to be a hydrophilic non-ionic surfactant. Okay, option number C is correct. Okay. Next, let's move on. What does AUC determines? So AUC, we have seen Cmax, Tmax, AUC as the important pharmacokinetic parameters. So AUC determines none other than the plasma concentration of the drug, actual plasma concentration of the drug and the extent also, right? So this AUC gives the actual integrated profile of the drug, okay? Next, complete wetting occurs when the contact angle is 0, 180, 90, 360. Contact angle and wetting are always inversely proportional. Lesser the contact angle, better will be the wettability. So for the complete wetting condition, the contact angle will be 0 degree. If it will be 180 degree, there will be non-wettable conditions. Okay? Okay. Next question. Most of the drugs absorbed via which of the following mechanism? We have bulk, facilitated, active and passive diffusion. More than 90% of the drugs, it is exactly given in your fingertips book, more than 90% of the drugs are absorbed via your passive diffusion process. Okay. Option number D here it is correct. Okay. Next question. Zeta potential is used for the determination of the stability of what? So zeta potential basically deals, I have exactly used the term coarse dispersion, the biphasic system, the suspension, emulsion where the stability is really need to be controlled. Okay. So in the zeta potential case, we have coarse dispersion as our correct answer. Next, which of the following is not the route of the drug elimination? Urine, definitely. Bile, definitely. Sweat, yes. Sebum, it is not a excretory route. So correct answer will be option number D, sebum, right? Sebum is the actually secretion of the sebaceous gland. Okay, so correct answer is option number D. Next question. Surface tension can be measured by one of the following. Capillary rise method, Dionoy ring detachment method, drop count method. Let's see how many of you answer. Those who are present must answer this question. I don't want this to be at least incorrect from your end. No, 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 no. One student has still mentioned capillary rise method. See, all the methods, Wilme dropped CD and ring in tension. Your Wilme plate method, drop number, drop count, drop weight method, ring detachment method, capillary rise method. All of these methods are for both surface and interfacial tension except for the capillary rise method, which is exclusively for the surface tension. But in this case, all these are also for the surface tension. So correct answer will be option number D. Yes, Wilme drop the CD and ring in tension. Okay. Next, for maximum bioavailability, drug should be targeted at what? Now these question is for our pharmacology experts. For the maximum bioavailability, the drug should be targeted at what? So the drug should be targeted at stomach? No. Stomach, for the most reason, it is going to figure out the drug to degrade the drug. But for the smaller intestine, we say the drug is maximum available in this case. Okay, so small intestine will offer the maximum bioavailability, offering a rich higher surface area, blood supply, and much more residence time. Next, bridge 35. I have just told you about the bridge and bridge. You must remember their names. So it is going to be your polyoxyethylene lauryl ether. Okay, direct answer question was asked from your table only, which I had showed you. Right, for the bridge, just we can correlate with one trick also. Right, we have where it is, yes, bridge 45. It starts from the M. We have monostearate here. Okay, we have monostearate here. Right, okay. Next, according to BCS classification system, drug having absorption first class higher permeability is only attributed only when the drug is having R higher than 90%. Okay, the drug has a higher than 90% permeability. Only then you put the drug as the high permeability classification. Okay, next. Tween 40. See, non-ionic surfactant span and tween. For the span we have sorbitan ester. For the tween we have polyoxyethylenes, polysorbates. Right? Then we have LPSO, laureate, palmitate, stearate, oleate. 20, 40, 60 and 80. Tween 40, it is going to be the palmitate ester only, right? So we have the palmitate. Option A is correct. Yes, correct. Shraddha, okay, right. Next, P-glycoprotein. Which of the following effect it is going to impart on the drug transport mechanism? You all have been taught in the pharmacology. This PGP, P-glycoprotein, it is the mostly known for the efflux of the drugs out of the actual site, right? So it causes efflux of the drugs. Correct, Karthik? We have correct answer option number A. PGP is actually known for not letting drugs to be actually accumulate at the target, but they cause their efflux. This is one of the important reasons for the cancer chemo resistance, also multi-drug resistance. This PGP is a major issue that is there. So in the case of anti-cancer drugs, certain anti-cancer drugs which are PGP substrates, obviously you have to give certain PGP inhibitors also. Okay, so this PGP are actually causing the efflux of the drugs through the ABC transporters. Okay, the HLB value of the detergent action or DS, please, this I expect from you all. Or DS, antifoaming, wetting, water in oil, wetting oil in water, then your detergents and then solubilizing agent. So down to 13 and 16 we will be having the HLB value of the detergent. Option C here is correct. Okay, fine. Next, BCS classification. Next, BCS classification, third, high solubility, high permeability 1, low solubility, high permeability 2nd, third will be high solubility and low permeability. Without any doubt, it will have high solubility and your poor permeability. So in this case, we have option number A only as correct because permeability is not mentioned. Okay, right. Next question. Kinematic viscosity is the ratio of dynamic viscosity to the, it is a direct question. Kinematic viscosity is none other than the dynamic viscosity upon density of the liquid, right? So correct answer will be option A. It is a direct statement based, formula based question. Kinematic viscosity is what? It is your dynamic viscosity upon your density, right? Okay. Next, example of drug which belongs to BCS class 4. BCS class 4 drug, that means poor solubility, poor permeability. Taxol, remember this thing, Taxol, furosemide, these are very much important examples, right? So option number D belongs to the BCS class 4 having a poor solubility and poor permeability. Option number D is correct. Okay. Next, anti-thixotropic behavior is shown by anti-thixotropic behavior. So for the thixotropic behavior, generally we say procaine penicillin G mainly shows the thixotropic behavior. For the anti-thixotropic behavior, we have magnesium magma. You can spot option number D, right? So option number D, magnesium magma, it is going to be the correct answer, right? For the thixotropy, please note, for the thixotropy we have procaine penicillin G. For the negative thixotropy, we have magnesium magma, right? Okay. Right. Next question. At 60, let's reach the question 60 and we will have a 1 to 2 minute break. Okay. Hydroxylation occurs in which the type, because it is, we have 100 questions today. So we are still left with one more hour of discussion. So I'll have a 1 minute break. Okay. Hydroxylation occurs in which type of biotransformation occurs, right? Hydroxylation occurs in which type? So the hydroxylation occurs mainly in the oxidation, because as the name suggests, right? So oxidation is going to occur. This is a biotransformation process. You must remember from the drug metabolism phase 1, phase 2. Phase 1 reaction includes functionalization reaction, where functional group is added to make the drug molecule more polar, that is easily excreted. Second, we have conjugation reactions in which the drug molecules are conjugated with a suitable conjugating agent and then they are made polar to be excreted. Second important point, if the size range of the drug molecule is less than 300, only then it will be excreted via urine. If it is more than 500, the major chunk is excreted via bile. Okay? Yes. Okay. Next, which type of the flow is exhibited by the Tregonth solution? So we have a plastic system. Most important example, Bingham bodies, flocculated suspensions. We have pseudoplastic systems, shear thinning systems. All the gums, mucilages, Tregonth, alginates belong to shear thinning pseudoplastic systems. For the deflocculated suspensions like zinc oxide in water, kaolin in water, so these are going to form in the dilated system, which are meant to be shear thickening system. So here we have a Tregonth solution, so it is going to be none other than our option number B, right? Gums are included here. Next, higher volume of distribution includes high volume of distribution. See, there are two differences with the distribution and the binding. I have confirmed that if the drug is more protein bound, it is going to be less distributed because it is associated with some proteins, which is limiting its ability to get distributed and go to multiple sites to get distributed and show the behavior, right, at the targeted site. But in this case, if the drug has higher volume of distribution, it will extensively show the drug distribution because it will let it to distribute among the various dispersed through the complete body. Okay, next, last question for before we take a minute break. Okay, next, so the cup and bob viscometer. Okay, it is this in which the cup and bob viscometer, in which stationary cup, see we have a cup stationary and bob is rotating. So in the cup and bob viscometer, there are two possibilities. In one possibility, cup is going to rotate. In the second possibility, bob is going to rotate. Okay, example of such is the Mach-Michael viscometer. Right, in this case, this is mainly known as the cuvette type. Mainly known as the cuvette type. In which the bob rotates, it is known as the Searle type. So the example also is none other than the Stormer viscometer. Right, so you can spot cup, cuvette, bob, Searle, Stormer. So this is the way you can remember, right? So in this case, the cup is rotating, cup is stationary and the bob is rotating. Bob rotates, so it will be the Searle type viscometer. Okay. Yes. So in this case, okay, answer is incorrect here, but definitely what I have told you is right explanation. Okay, let's see the explanation. In the rotational viscometers, you have seen the cuvette type. See, I have told you the explanation was correct. The cup is revolving in cuvette type. Example was Mach-Michael viscometer. The bob is revolving in the Searle type. The example was the Stormer viscometer. So our explanation and answer option B is correct. Okay. So it's 9:03. Let's wait for 30-40 seconds. Let's take a 1 minute break and we'll be back. Okay. So we have still few many questions, that are 60 questions are covered, 40 are left. So please buckle up, take a water break and let's get back to it. Okay, so we are back now. I need your attention to the next question. So the question says the biotransformation reaction that involves in the metabolism of the methyl dopa is acetylation, sulfation, oxidation, N-oxidation or S-oxidation. So you all have seen the structure of methyl dopa. You all are aware of the structure of methyl dopa. I am not a medicinal chemistry expert. You all are, right? So for the methyl dopa with the functional group, you must see that the N-oxidation is going to be the particular biotransformation reaction in which the phase 1 metabolism is happening. Addition of the functional group is happening here in this case of the N-oxidation, which involves by the methyl dopa, right? So in the S oxidation, which is the involving the sulfur groups, so in the methyl dopa we do not have any sulfur, so correct answer was option number oxidation. Next, Oswald viscometer is used for the which type of liquid? So these viscometers, if you remember, so if somebody asks you the base or the classification of the viscometers, this is another important topic. So viscometer is basically classified as single point viscometer and multi-point viscometer. Single point viscometer and multi-point viscometer. The single point viscometers are for the Newtonian fluids. The multi-point are for the Newtonian and the non-Newtonian fluids. So for the single points we have some important example as your Foch. We will say Foch. Foch stands for the falling sphere viscometer and the example for the same is the Hoppler viscometer, right? So this F and H are correlated. Then we have the capillary rise viscometer, capillary, in which the example is the Oswald viscometer. So you can spot this O and C are relevant, F and H are relevant, right? Okay, so in this case, this is for the Newtonian because this is a single point viscometer. If it would be a multi-point, it is for both Newtonian and non-Newtonian, whereby you can remember it as CCB, cup and bob, cone and plate, and rotational with torque we have Brookfield. So this Brookfield has a T-shaped spindle. Note down, it has a T-shaped spindle. Okay, so we have these as single point and multi-point viscometers for the determination for the Newtonian and non-Newtonian flow. Next, the initial distribution of drug into the tissues is chiefly determined by, so the drug distribution into the body by the rate of the blood flow into the tissues. Okay. Next says the plasma protein binding of the drug, the gastric emptying rate or the affinity for the protein. So for any drug, initial distribution will correlate to the perfusion rate, the rate of the blood flow, right? Because it has just entered the your systemic circulation, it will definitely involve the rate of the drug, that is perfusion rate through which the drug will be able to flow and enter into the different tissues. Okay. So we have a right answer option number A. Next, SI unit of viscosity is poise, centipoise, mm or dm. See, all these are incorrect from my understanding. So actually these are the CGS units. This poise is a CGS unit. The SI unit is Pascal second, right? Note it down, the SI unit is actually the Pascal second. Okay, so this none of these should be the answer, but okay, if it is says poise, poise is the CGS unit, not the SI unit, right? See, as I've mentioned, this is a confusion. The CGS unit is actually it is the poise. For the SI system, it is for the Pascal second. Okay, must remember these points. Next, acidic drug binds to which of the protein? See, we have very different kind of proteins for the drugs to be able to bind. We have albumin, alpha-1 acid glycoprotein, we have lipoprotein, we have globulins as well. So in the acidic drug basically binds to the albumin. Most of the drugs bind to albumin only. Basic drugs bind to the alpha-1 acid glycoprotein. Note it down. Okay. Next. The type of viscosity specified in IP, Oswald viscometer. Generally, your both dynamic and kinematic viscosity both are considered, because once we were previously we were seeing the formula for the kinematic viscosity also. It involves the dynamic also, right? So correct answer is both. Okay. Next. Which type of the drugs are ionized at all pH values and their absorption is rapid, unionized, and the pH is independent? This you must answer. You have seen that one chart where we have put down the drugs based on their pK profiles. Are they going to be unionized, ionized? Are they weakly acidic, weakly basic, strong acid, strong base? Strong acid and strong base both are going to be ionized anyways, right? So please eliminate those options. But the weak bases are going to be unionized. Okay, very weak bases are going to be unionized. You can spot this table again for the very weak acids and very weak bases, right? Very weak acid and very weak bases. See, the pK is relevant to the acid and basicity. pK is inversely proportional to the acidity. That means if a drug has higher pK, the acidic nature will be lesser. Okay. Next, unit of rate constant for second order reaction. Chemical kinetics question. So unit for the first order, it is very clear from the T half. Even if you do not remember the rate equation, T half was for the first order 0.693 upon K. So it will be R inverse, second inverse, right? For the first order, for the second order, you should remember. So for the second order, it is liter mole inverse, second inverse, right? So for the first order, it was mole per liter per second. For the second, it was second inverse. For the second, for the first, it was second inverse. For the second, it was liter mole inverse, second inverse. If you ever want to remember these, you can directly remember, or you can spot the T half equations. It is very, very easy for you all to see that. Next, which of the following easy cross the blood-brain barrier? In fact, for the drug to be absorbed in the first class of the general pharmacology in the biopharmaceutics, I always say acidic drugs, acidic pH, unionized. Basic drug, basic pH, unionized, better absorb. For the absorption, you need good permeability, right? So for penetrating the blood-brain barrier, it should be the unionized fraction. Okay, there should be no doubt about it, right? Next, half-life for the first order. Tell me if you don't know it. From the 11th and 12th class, right? Right from our school, we know that for the half-life for the first order is 0.693 upon K. Without any doubt, our option A is correct. Okay? Okay. Right. Next question. If this is going to be a little solving part, but I hope you are aware about the formula. So let's see. If the plasma drug concentration is 20 microgram per ml, plasma drug concentration is 20 microgram per ml, the dose of the drug is 100. You need to calculate the volume of distribution. Do I need to tell you the formula again? Because in today's class only, I have told you that the formula is going to be X upon Cp. You can do this much effort. This X is 100 upon 20. So you get the correct answer as 5 liter. Option number A is correct. Okay. Next question. Arrhenius equation is used to determine the stability using the plot of everybody knows. Arrhenius equation involves the temperature, right, and the rate of the reaction, right, indicating the stability of the drugs as well. So it will indicate the log K versus 1 by t, because here the log k exists. That is why I have put the 1 upon t based on the equation. If you remember, it is k is equals to a. I'll write the equation for you if you do not remember. It is k is equals to AE minus EA upon RT, activation energy, right? And here we have temperature. We have just put these values into the logarithmic scale. Okay, that is why the T is as 1 upon T. Okay, next. GFR indicates about how much value. I have told you the value is around 125 ml per minute or 180 liter per day. Okay, so here it is close to 120 ml per minute as our correct answer, right? Okay, next, the rate of kinetics deal with concentration, order, molecularity, all of these. So, order and molecularity are two different things. But the rate kinetics is definitely relevant to the order. It is the zero order kinetics, first order kinetics, second order, and so on, right? So the rate of the kinetics do deal with the order of the reaction, not the molecularity. Okay, right. Next, main purpose of the phase 1 metabolism. See, I have initially informed you, phase 1 is the functionalization reaction, whereby the drug molecule is converted into a polar metabolite using oxidation, reduction, hydrolysis, and so on. For the phase 2 reaction, it is the conjugation reaction where we have glutathione, right, glucuronidation, we have methylation, sulfation, acetylation, in which we have a conjugating agent as well. So, those are synthetic reactions and these are functional. Group demasking is basically done. Demasking means exposing the functional group, right? Next, all are phase 2 reaction except, so phase 2 reactions do not involve the oxidation as just we have discussed, right? So option D here is the correct answer. Okay, next, rapid increase in the solubility of a surfactant solution above a definite temperature. Rapid increase in the solubility. Now, if is it cloud point, is there any cloudy appearance that is happening? Not at all. Triple point, am I talking about any supercritical fluids or any point where the solid, liquid, gas all exist together? No. So triple point, this was asked in GPAT exam, triple point this time, right? Then CMC, above which they are going to orient as the micelles, not at all. So in this case, the answer will be your craft point. Option B here is correct. Definitely statement based question was asked. Next, full form of CMC, just mentioned critical micellar concentration, right? CMC, from the surfactant you can see how many I have just seen in the 2022, 3 to 4 questions are from the surfactants topic only. Okay, next, main organ which is involved in the elimination of the drug. While I was telling about the metabolism, I have mentioned the size ranges. If the drug molecule has a size less than 300 Dalton, definitely it is going to be eliminated via urine. If the size range is more than 500, it will be eliminated via bile. But if it is between 300 to 500, note down it will be for the both urine as well as bile, depending upon the nature of the molecule. So in this case, for the major elimination will be from both kidney and from the liver, right? Major metabolizing eliminating organ. Next, gelatin has a gold number value, which means that, see, higher gold number value or least gold number value. Okay, gold number is inversely proportional to the protective ability of the colloid. So if the protective ability is higher, that means the gold number was lesser, right? So gelatin, if it has a lesser value of the gold number, it will be a more protective colloid. Option B here is correct. Okay, please note down these values, also very important for the Tragaganth. It is to, sometimes the trend gets repeated, you never know, the question gets asked on this simple topic also. Tragaganth 2, acacia 0.1 to 0.2, albumin 0.1 and gelatin is very less 0.005. Next, drug metabolism is affected by vitamins, minerals, metabolism inhibitors or trace metals. Please answer. Drug metabolism, basic interaction question. So, drug metabolism will be affected with the presence of the metabolism inhibitors, right? It is very much evident. It will be affected by the presence of the metabolism inhibitors. Okay. Next, which of the following organs play an important role in phase 2 metabolism? So, phase 1 metabolism or phase 2 metabolism, functionalization reaction, conjugation reactions. So any which way, the liver is going to play a much important role. It is all happening in the liver, right? Okay. Next, Fick's law of diffusion can be represented by which equation, right? So Fick's law of diffusion, we have two Fick's laws, first and second. So all the statements you can spot here are for both first and second also, right? So Fick's law of diffusion is represented based on the flux value. It is calculated using all these three formulas. Let's see. Fick's first law indicates what? It indicates that the rate of the, please note down, very important, it is for the rate of diffusion of solute molecules through a barrier. It is proportional to the concentration gradient. This is the Fick's first law. Fick's second law involves the time at a particular region, which is proportional to the concentration gradient based on the change in the concentration occurring at that particular time. Okay, so all these three formulas were there. Please note them down. Next, paddle over disc based on the apparatus. So we have classified as IP and USB. IP is paddle, basket. USB apparatus, what are those 7 apparatus names? So based on USB apparatus, we have basket, paddle, reciprocating cylinder, flow through cell, paddle over disc, cylinder over disc and reciprocating holder. So we have these 7 types of USB apparatus. So 1, 2, 3, 4, 5, 6 and 7. So paddle over disc is none other than our option number 5, type 5 USB apparatus. Okay, so we have, you can see, basket, paddle, reciprocating cylinder, flow through cell, paddle over disc, cylinder over disc and reciprocating holder. Okay, next, which among the following is a phase 2 drug metabolism reaction? So phase 2 involves the addition of the conjugating agent and we have certain enzymes. Generally the transferase enzymes are used for making the drug metabolite more polar, right? So we have oxidation, conjugation, reduction or hydrolysis. So in this case you can spot the conjugation to be a phase 2 metabolism reaction, right? Correct answer will be option number B. Next, type 1 dissolution apparatus. Type 1 we have already seen based on IP, it was paddle, then basket. For the USB, it is type 1 is our basket type apparatus. I hope these questions are simple to answer for you all. Okay. Next, phase 1 reaction occurs mainly in. So phase 1 reaction mainly occurs in the cytosol part and the phase 2 reaction occurs mainly in the mitochondrial region, right? So phase 1 reaction phase 1 reaction is mainly in the endoplasmic region and phase 2 metabolism is mainly in the cytosol. Okay. Next, Hansen paddle apparatus for the dissolution testing of what? So these dissolution testing apparatus are designed for the tablets only. Okay, majorly for the tablets. So we have our option B as correct. Please note down, these dissolution apparatus are mainly for the your tablets. Okay. Next, which of the following is extensively metabolized? prazosin, clonidine, lidocaine or sotalol, right? So this is question you can correlate with the ecology also. Here the correct answer is going to be the option number C, lidocaine, right? So let's see prazosin, which is offers the moderate hepatic metabolism. Please note down, prazosin offers the moderate hepatic metabolism. Clonidine is partially metabolized. Lidocaine, however, is extensively metabolized, and sotalol, important point, is excreted unchanged in the urine. Okay. Alright. So next, dissolution apparatus type 4. Dissolution apparatus type 4 is flow through cell, basket, paddle, reciprocating cylinder, flow through cell. So correct answer is flow through cell apparatus. Option number D is the correct answer. Okay. So type 4 apparatus is the flow through cell based on the USP. Okay. Next, which of the following technique is used for studying the protein drug binding? So protein drug binding is offering the equilibrium dialysis, ultracentrifugation, gel chromatography or all of these. So for the protein drug binding, actually all of these techniques are used, right? So it is a direct question. So all these methods are used. Option number D is correct. Okay, so we have certain indirect techniques, we have direct techniques, right? In the indirect techniques, we have equilibrium dialysis, dynamic dialysis, ultrafiltration, ultracentrifugation and gel filtration. In the direct techniques for the protein binding, we have spectroscopy methods, right? And fluorimetry methods as well. According to USP, type 2 dissolution apparatus. So according to IP, it is paddle, basket. According to USP, it is basket and then paddle. So based on type 2, it is going to be the your paddle apparatus based on the USP. Okay. Next, which of the following is the phase 2 reaction metabolism? Phase 2 metabolism reaction. Phase 1 we have already covered, which were the oxidation, reduction, hydrolysis, acetylation. All these are phase 1 reaction. Sorry, oxidation, reduction and hydrolysis. However, the acetylation is the phase 2 conjugation reaction. Right? For these conjugation reactions, we have conjugating agent and conjugating and transferring enzyme. So for this we have N-acetyl transferase, which shows is extensively in the genetic polymorphism. We have seen NAT1, NAT2. Second thing is the acetyl coenzyme A, which will be your in this case the main conjugating agent. You have heard about all these. We have the trick as games, right? We have glucuronidation, we have glutathione conjugation, we have alpha 1 amino acid, we have then acetylation, amino acid conjugation, acetylation, we have methylation, we have sulfonation. So all these are phase 2 reaction. So all these have a conjugating agent, glucuronic acid, right? We have glutathione, right? Then we have glycine, acyl coenzyme A. Then we have acetyl coenzyme A. Then we have methylation, right? Then we have for the sulfate for the sulfonation. Okay, methionine for the methylation. Okay, so option number D here is correct. Next, 𝙂𝙂 equation. Tell me if you are not aware about it. Whenever we start the drug dissolution process, we first note that this is equation which gives the criteria for the drug dissolution process based on the surface area, partition coefficient, concentration in bulk, concentration in the subspace, the saturated phase or the bulk, and then the other phase, right? Comparative evaluation, we have the modified 𝙂𝙂 equation that we nowadays use. Simplest Navier-Stokes equation is the dC upon dt, which is the dissolution rate, is equals to dissolution rate constant, concentration of the stagnant layer minus concentration of the bulk. It is now being modified. Next, select the correct statement for a prodrug. Bioreversible derivative of the drug, inactive precursor of the drug, improves the absorption, or all of these. So it was asked in 2003. So it is correct. Prodrugs can be formed as an active drug into an inactive metabolite, or inactive drug into an active metabolite. This is a prodrug approach. Or active drug into a more active metabolite. So this is all based on the drug modification as well as the nature and activity you are targeting, right? Okay. Next, first pass metabolism occurs when the drug is administered. So we have all done with our pharmacology, our biopharmaceutics. Definitely the oral route is the major chunk that causes the first pass metabolism effect. Okay. Next, pre-systemic metabolism results in, that means we are talking about the first pass metabolism that results in the decreasing the half-life of the drug, reduces the bioavailability of the drug. Okay, correct answer was option number C. Next, choose the correct formula for the clearance. I have told you, if biopharmaceutics is asked, numerical, there are least chances, but formula based questions can be asked. Okay, stay prepared for the clearance. It is elimination rate upon plasma drug concentration, right? Option A is correct. But I have told you multiple other formulas as well. Clearance is equals to Ke into Vd, right? If you want to substitute it, it will be 0.693 upon T half into Vd, right? There are one more formula. Clearance is equals to R naught upon, this was your formula for, I think, the R naught upon CSS it is, or what it is. Please check this formula. In the IV infusion I have told you. Okay. Then for the loading dose, for the maintenance dose. Please note these formulas. These are very much important, whereby the clearance questions can be asked. Okay. No, that is actually R naught upon Cl is the formula. In the case of the IV infusion process, R naught upon Cl was the actual formula. Okay. Yes. So here the correct answer will be option number A, based on the elimination rate upon the plasma drug concentration. Then more formulas we have: urine concentration upon plasma drug concentration into urine flow rate. Very important, these formulas. Then we have renal clearance ratio based on the renal clearance of drug to the renal clearance of the creatinine. Okay. Then biliary clearance will be biliary clearance rate upon plasma drug concentration. Next, steroids can be metabolized by which of the following reaction? Can it be your option number A, glucuronidation? It is correct. Sulfation, yes, it is also correct. So these are metabolized by both your phase 2 reaction, glucuronidation as well as sulfonation, right? Based on the type of the nature of the compound. Okay. Next, which creatinine clearance values shows moderate renal failure? See, creatinine clearance value is attributed to more of the GFR, which is 125 ml per minute, or range is 120 to 130. Fine. But if it drops down to 20 to 50 ml, it indicates moderate renal failure condition. But if it further drops down to below the 10, it indicates severe renal failure. So, dear students, we have creatinine clearance around 20 to 50 indicating the moderate renal failure. But if it drops down below 10, it will indicate severe renal impairment. So, before I leave, I request everybody to at least spare 30 minutes extra after this class and just note down all the formulas on a single page for the clearance. Okay. Next, anything you are still afraid of, you have gone through GPAT, you will go through NIPER, then you will be getting admissions into your M Pharma and struggling anywhere. We are always available for your guidance. We have multiple channels. We have seen GDC jobs is their career. We have one MCQ channel, main channel, English channel. Everyone is working for you all. You need not to get afraid at all. Secondly, as of now, we have the most priority of our NIPER exam. Focus on that exam, clear those exam. You have to make yourself, your parents, as well as GDC proud of you all. Okay. Thank you so much. We shall meet very soon, and I should be able to read your all names in the toppers list as well. Thank you so much. We will meet soon.